Okay, this video is about discrete probability distributions and just general properties of all probability distributions. So there are two requirements for probability distributions of any type. And that is first that the sum of all the probabilities are equal to 1, and the individual probabilities are between 0 and 1 always. So let's first talk about what is a probability distribution. A lot of times people hear the phrase all the time in class, they don't really know what it is. What you want to think about is for any event, let's say it's a simple event like I'm going to take 3 paper balls and toss them into a basket, right? I'm going to see the probability that X of them go in. So X can maybe range from all 3 go in to none of them go in, right? And in that case, I could list the different probabilities of the outcomes. For example, I would have the probability that none of my attempts go in, right? And I could list that probability. I could have the probability that 1 of the 3 go in. That means I miss 2 and I make just 1. I could have the probability that I make 2 of the 3 but miss 1, or the probability that I get all 3 to go in successfully. So this could be a list of the possible outcomes when tossing 3 paper balls into a basket, right? All right, now when you think of probability distribution, you're trying to think of basically what creates it. In this case, this is a discrete probability distribution. What makes it discrete is that these x values are discrete numbers. We don't have any decimals, or we can get 0 and we can get 1, but it's impossible to get half. I can't say half of a ball went into the basket, either went in or it didn't, right? So that makes the list here discrete. This is a discrete probability distribution in that case. What we talk about when we talk about probability distributions is the idea that we want to list the number of possible outcomes that can occur, and we want to list all the associated probability with those outcomes. So basically we want to get a collection of all the conceivable ways it could turn out, and then have all the probabilities associated with those outcomes. When you've done that, you've got a probability distribution. It must adhere to these 2 rules, though. So what are these 2 rules? This one says that the sum of the probability of x is equal to 1. But that means if you add up all these probabilities, it has to add up to the decimal number 1, or in percentages 100%, which should make sense. If you have all the possible outcomes, you add all their individual probabilities together, it has to add up to 100% of the cases, right? So you have to have 100% of all the possible probability. Okay, let's check that, make sure this adds up to 1. 3% and 19% make 22. 22 and 44 make 66. And 66 and 34 do in fact make 100. So we realize that that's 100%, or the decimal number 1. So it checks on that front. All the probabilities add up to 1. The other thing we have to make sure is that each individual probability is a proper probability. Proper probabilities must range between 0 and 1. They can be 1, they can be 0, but they can't be anything negative or anything higher than 1. So when I look at this, I say, okay, is that within that range? Yes, it is. Is that within the range? Yes. Is that within the range? Yes. Is that within the range? Yes. So all of these are okay. So each probability in the list adheres to this rule. The total sum of probabilities is 1. This makes this a proper probability distribution. This would be basically, like I said, could be, for example, the probability that I make X number of baskets out of 3 attempts, right? The maximum I can make is 3. The minimum I can make is 0. 1 and 2 are also possible, and there's the associated probability.